In the previous class, we have seen the applications that are scrolling on the screen. You can see I discussed about the applications of differential calculus in different sectors. And let us give a glance to all the concepts once, and then we will move on to the advanced level problems. Okay, so let me start, please. This is in the functions. He mentioned about the number systems first, which I need not have to revise, and independent variable, dependent variable. This you must know. What is an independent variable? What is a dependent variable? If you take a function in the form of y is equal to f of x is independent variable and y is dependent variable. Why is it so? If you give different values to x, then you will be getting the result. So this is input, I can say. This will be output. For example, if you take the volume of a sphere, volume of a sphere is 4/3 pi r cube. And do you tell me which is independent variable and which is dependent variable in this case?
Dependent is volume, independent is radius.
Very good. So radius is independent, please. And dependent is volume. Like this it goes practically in the problems. You must understand like that. Input and output, domain and range. And all these are nothing but independent variable, dependent variable. In other words, independent variable is the domain and dependent variable is the range. Okay, now these are all the absolute value properties, which is most important throughout the calculus, is that if you take any square root of x square, you are habituated to write plus or minus x or simply x. But you must write it as mod x, and that mod x becomes minus x if x less than 0 is equal to 0, if x is equal to 0 is equal to plus x if x is greater than 0. Very, very important, please. Very, very important. Knowingly or unknowingly, you neglect this. So you should not do that. For example, if you get a quantity under the root like this, x minus 2 whole square, you may be writing it as x minus 2 or plus or minus x minus 2. Instead, you must write it like this, and after that you have to split it like this. Becomes x minus 2 if x is greater than or equal to 2. Becomes 2 minus x if x is less than 2. This you must remember, please. Absolute value of the function. Very, very important, please. Next one. the inequality, everyone knows, I need not have to explain you that modulus of x is less than or equal to a means x lies between minus a plus a. And modulus of x greater than or equal to a means x never lie between minus a plus a. X never lie between minus a plus a. Okay. So less than lies and greater than never lie between. I need not have to explain that in all that. And this inequality is also very, very important, please. These inequalities with regards to modulus, even in complex numbers also, you'll be getting this type of inequalities. Modulus of x plus or minus y is less than or equal to mod x plus mod y. And modulus of x plus or minus is greater than or equal to mod x minus mod y. Modulus of xy, no need to remember them separately, mod x into mod y. Similarly, modulus of x divided by y is mod x by mod y. In case of addition only, you should not split as you like. So modulus of x plus y and modulus of x plus mod y is to be written. Then how do you remember this? How do you remember this? Is not by hearting. You just do it like this. You write it as one number as 2. It should be true for all real number system. I'm writing x as 2 and y as minus 1. Then what is 2 minus 1? It is 1. And what is mod 2? 2. What is modulus of minus 1? 1. What is 2 plus 1? 3. Which is greater? 1 is lesser, 3 is greater, and hence you have to write like this. Everything can be written like this using some real number system. So you need not have to separately by heart it. Okay, next, greatest integer function, which is very, very important in different functions. Greatest integer function. Everyone knows that. I think if you forget it, you have to revise it. That is always the step function or greatest integer function lies between x minus 1 and x. It is equal to x, or it must be lying between x minus 1 and x. So this is the property of greatest integer function. And why is it said to be a step function? The reason is, if you see it's a graph, the graph will be formed like steps. So this is the most important one. You have to revise if you forget it, because we are learning in the advanced level, and I'm not taking up all the concepts, but just I'm revising the concepts. Remember that. Similarly, this is denoted by step x. Always you'll be getting with square brackets of x here, and they will separately mention it as this point in the square brackets as GIF, which is greatest integer function. Similarly, fractional part of x is nothing but x minus step x. It accepts only the fractional part of it. And let me show you the graph briefly so that you will also be remembering. If you take the graph of this one, step x, the graph of step x goes like this. This is x-axis and this is y-axis. And if you take the step function is greatest integer function. Greatest integer function will be like this. Between 0 and 1, it goes like this. Between 0 and 1, it is 0 only. Between 1 and 2, it is 1 only. Between 1 and 2, it is 1 only. And between 2 and 3, it is 2, please. Between 3 and 4, it is 3. Like this, it forms like steps. It forms like steps. This is called step function, please. And you must be knowing how it varies, how it varies if it is something like step of x plus 1, step of x minus 1, and all this you must be knowing. This is about the greatest integer function. Whatever the value you give, it takes only integral part of it. It takes only integral part of it. If you want to understand, this is what I'm talking about is y is equal to step x. Okay, now if you want to understand the fractional part of x, y is equal to x minus step x, please. Y is equal to x minus step x. It is denoted by flower brackets x. Flower brackets x is nothing but fractional part of x. It accepts only fractional part of the given value. Just it is exactly opposite to greatest integer function. This is greatest integer or integral part. So what happens now, this because it is greatest integer function, it takes only integral part, which is a fractional part of x. It accepts only the fractional part of it, and hence this graph goes like this, and it will be lying between 0 and 1 only. It always lies between 0 and 1 only. What I mean to say, this is 0, this is 1. All this will come down between 0 and 1. So the range of x minus step x is 0 and 1. So it goes like this. This is between 0 and 1. And this is between 1 and 2. And this is between 2 and 3. This is between 3 and 4. Like this it goes. Like this it goes. Okay, so this is fractional part of x, and it is even periodic. Whereas greatest integer function is not periodic, but this is periodic. Fractional part of x is periodic, and its fundamental period is equal to 1 place. In the interval of 1 it repeats. That is why it is said to be fractional part of x. Okay, so that's what I'd like to revise, and let us see now. Let us continue fractional part and greatest integer part. Intervals I do not want to discuss because everyone knows it. And definition of function, and if you see the definition of function, no element of the domain. This is called domain. This is domain, and this is range. No element of domain should be left without image. This is not a function, remember that, because there is no image for this one. And this is not also a function because there are two images for this element here. So if you understand which is not a function, then you'll better understand which is a function. So no element of domain should be left without image, and no element of domain should have more than one image. Such relations, such are called relations but not functions. So function will be defined as f is said to be a function if every element of set x here, has one and only one image in the set y. One and only one image in the set y. Then it is said to be a function. That is a function definition. Or function definition, if you want to verify whether the given relation is a function or not, just you have to do it like this. You have to do it like this. Like what? If you take a function like this, y square equal to x is there, for example, you want to check whether it is a function or not, just draw its graph. Just draw its graph. If you draw its graph, then it will be like this. It will be like this. And how to check whether it is a function or not? See, then you have to draw a line parallel to y-axis, please. You have to draw a line parallel to y-axis like this. If it is intersecting in more than one point, if it is intersecting in more than one point, you know, that is not a function. That is not a function. Why is it not a function, please? Why is it not a function? Because for a value of x, you have two y values here. That is, x has two images. X has two images, which is against the definition of the function, and hence it is not a function. Similarly, if you take x square is equal to y, for example, x square is equal to y is the function which is, it takes the parabolic form. It takes the parabolic form. I need not have to tell you that. So this is x square is equal to y, let me say. Then if you check now, it intersects only in one point, and hence it is a function. Is a function. Not a function. So like this, we verify the given relation is a function or not by drawing a line parallel to y-axis. If it intersects only in one point, we say that it is a function. If it is intersecting in more than one point, then it is not a function. Similarly, if you want to check whether it is a one-one function or not, then simply you have to draw a line parallel to x-axis, please. If it is intersecting only in one point, this is not at all the function, first of all. So I'm removing this. I'm removing this. This is not at all a function. Remove. Now, if you draw a line parallel to the x-axis, if it is intersecting in more than one point here, if it is intersecting in more than one point here, then it is not a function. Then it is not a one-one function, please. It is not one-one. Why not 1, 1? 1, 1 means in the name itself, we have the meaning of it. One element will have only one image. Of course, it is definition of the function only. What I mean to say, 1, 1 means every element should have different images. Every element in the domain must have different images. But here, if you check now, if you check, for this value of y, there are two x here. This is 1 plus x, other one is minus x. You can check it out. This is x is equal to plus or minus root y. That is why it is not a one-one function, and even one-one function can be verified through differentiation. If the first derivative is strictly 0 or strictly less than 0, if the first derivative is strictly 0 or strictly less than 0, then we say that this function is monotonically increasing or monotonically decreasing. Whatever the monotonically increasing function or monotonically decreasing function is there, always 1, 1, please. They're always 1, 1. So we'll be knowing that. We'll be knowing that further. But these are the concepts to be revised, and very important topic is functions. Functions is a very, very important topic, and without the question from the function, mostly no question paper, not mostly, no question paper will be there in the entrance examinations. So functions is very, very important, and I'd like to know whether functions is there in your 12th or not.
No, sir.
No, sir.
Don't have? Because in CBSE, functions is distributed between 11th and 12th. That is the reason why I'm asking you, because Maharashtra State Board, they follow almost the CBSE curriculum only. The textbooks also on par with CBSE textbook, NCERT textbooks. I think in your 12th, you must have functions. Anyone, do you confirm with that? Whether it is correct or not?
Sir, I'll check, sir. One.
Check it out once, and confirm me, please. Okay. So, testing for a function by vertical line test. That's what you can see this. This is intersecting in 2 points, not a function. It is intersecting in more than 1 point, not a function. It is intersecting only in 1 point. It is a function. It is intersecting only in 1 point. It is a function. This is what you have to understand. A number of functions is to be found out using permutations and combinations. Permutations, if you see, this is
Yes, sir, we have.
it is n of b whole power n of a. What is that you said, Dhananjay? We have, you have in 12th now?
Yes, sir.
Oh, someone is saying no. That is
No, sir, 11th also we have and 12th also we have.
That's what I said. In NCRT, the entire topic is distributed in 11th and 12th. Then in such case, you have that in 12th also. That means you have to learn every method. You have to learn every method theoretically also. Theoretically also, because functions is a part of your board examination. Functions is a part of your board examination. That's what I'm saying. So number of functions, how do we calculate number of functions? Let me revise this once briefly. See, whenever there are some elements in set X and set Y, let me say, this is set X, this is set Y, and there are some elements here, X1, X2, X3, Y1, and it is X4. And you have elements here Y1, Y2, Y3, Y4, Y5, Y6. Then you want to understand the number of functions here, different types of functions, whatever it is, it should be a function. To get different functions here, what is the rule to be followed? X1 can be mapped to any 6 of this. Any one of these 6, I mean to say. Any one of these 6. Not all 6, not more than 1, please, but not more than 1. So X1 has how many chances here? X1 has 6 chances. Even X2 has 6 chances. And X3 has 6. And X4 has 6. So it is
And y raised to n.
6 power 4. 6 power 4 different types of functions that can be formed. That's what I wrote it as. N of b whole power n of a gives you the total number of functions. Total number of functions. Understand that?
So for our 12th we have functions, but we only have trigonometric functions.
Yes, sir, we don't have functions.
हाँ, functions as a whole chapter. वो गवर्नमेंट टेक्स्ट बुक में पूरा 11th में हम लोग.
अच्छा, मतलब जो 12th में है वो ही पूछेगा क्या?
हाँ सर.
अच्छा, थ्योरम्स है उसमें? ठीक है, ऐसा कुछ नहीं रहेगा यार. और ट्रिग्नोमेट्री का अलग हो गया, इसमें नहीं है बोल के ऐसा नहीं बोल सकते. फंक्शंस कवर्स ऑल व्हाट आई से. You cannot say that trigonometry is not there because functions means it may be trigonometric, it may be logarithmic, it may be exponential, it may be inverse trigonometric, whatever. It covers everything. Okay, so this is n of b whole power n of a gives you the total number of functions, please. Okay, so this is about the number of functions, and similarly you have domain and codomain. What is the domain, please? Domain is input and codomain is the universal set of range. Range is the subset of codomain. Range is nothing but the set of those elements that are mapped here, that are associated here. So here the domain is ABCD and codomain is PQRS. Just see this. Domain is ABCD and codomain is PQRS and range is only PQR. Remember that. The elements that are associated only will be taken as the range. Okay. So now let us understand. Finding the domain and range is also very, very important, please. What I mean to say. Finding the range, domain and range is also very, very important, what I'm saying. Okay. So, methods to find the domain and range of function, this we will be discussing in the problems. Finding the domain means you should not give those values to x which undefines the function. You should not give those values to x which undefines the function. For example, tan x is there. For example, tan x is there. And tan x consists of, is the ratio of sin x and cos x. You should not give those values to x
Where
for
cos
cos
is
x,
equal
it
to
is
0.
not equal to 0 because the denominator becomes 0 and thereby you will have that function undefined. So x is not equal to pi by 2, 3 pi by 2, 5 pi by 2, etc. Okay, that's it. So next, this is about the domain of the function. Mainly we follow the values of x which undefines the function. We don't take. For example, it is a combination of two functions. Then we take the intersection of the domains of individual functions. In the addition or subtraction or multiplication or division, even in the square root also. Whenever the combination of two or more functions are there, we'll have to take the intersection. We'll have to take the intersection, that means the common values of the domain. And range, little, when compared to domain, no, finding the range is little, what should I say, little tricky, I must say like that. So range, you must be aware of the you must be aware that range is nothing but the output. Range is nothing but the output. So depending on the given value input x, you have to count the value of y, which is the range. Okay. Now, and these are all the problems in the main level. Just to revise them to be thorough in the advanced level. You have to revise, please. It was covered long back. It was covered long back. I made you did all these problems, but only thing is it is to be revised. Without revising all this, going or jumping to advanced level is totally meaningless. So you have to revise them, please. Next, algebra of functions, addition, subtraction of functions. It is shown like this: f plus or minus g of x is f of x plus or minus g of x. And the multiplication of functions f g of x or g f of x is nothing but fx into gx. And division formula, which is f by g of x, is nothing but f of x divided by g of x. G by b, f of x is nothing but g of x by f of x is about the algebraic operations. And then coming to equality of functions. Two functions are said to be very, very important, please. Two functions are said to be equal only when their domains are same and their codomains are same. Here it is given, of course, but the second point need not happen. And the third point must happen. So 1 and 3 must happen. What does it mean? Very simple. Domains must be same and ranges must be same. That's it. Two functions are said to be equal only when their domains are same and the ranges are same. Okay. So this will be applying in the equality of two functions. Okay. Next is kinds of function. Just now I discussed. It is one function injection. In the name itself, you have the meaning of it. Different elements will have different images. Different elements will have different images. It's nothing but one function. In the verification, just now I said, you have to draw a line which is parallel to x-axis, and if it intersects only in one point, then we call it as a one function. If not, it is not a one function. It becomes a many-to-one function. All non-one functions, I repeat, all non-one functions are many-to-one functions. Okay. Now that is a graphical method I taught you, and if it is the theoretical method, then we will take two arbitrary constant x and y in the domain, and we write their corresponding images, and we equate them. If we equate them, their pre-images must also be equal. F of x is equal to f of y. If you write forcibly, then you must get x is equal to y. Then only it is one function. We'll be understanding that, no problem. For example, fx is equal to x square is there. If you want to understand whether it is 1 or not, theoretically, then we choose two elements in the domain x1 comma x2. What is that? We choose two elements in the domain as x1 comma x2. Then this belongs to the domain. Then fx1 comma fx2 belongs to the range. Okay. If it is 1, no, if you equate the range elements, f of x1 is equal to f of x2, then you will have x1 square is equal to x2 square. Then x1 is equal to plus or minus x2, not 1, like this it is. This is theoretical method. Okay, this is what you have to understand with regards to the verification of injectivity of the function or one function. Okay, similarly, graphically, just now I said, if you take a straight line, this is a straight line. If you draw a line parallel to x-axis, it is intersecting only in one point, and hence it is a one function. Similarly, here also it is intersecting in only one point, and hence it is a one function. If it is intersecting in more than one point, it won't be one function. Then if it is not one function, what should it be? It should be many-to-one function. It should be many-to-one function. Now the number of one functions, please, it is nothing but permutations, NPR. Nothing but permutations. In the previous case, what I explained is 6 power 4 I have taken. Do you remember? Respond, please. 6 power 4 I have taken. In the previous example, what I have taken. But for 1, what happens, you know? It will not be 6 power 4, but it is 6 into 5 into 4 into 3, which is nothing but 6p4. 6p4 gives you 1. 6 power 4 gives you total functions. What does it mean by total functions? All one functions will be there, onto functions will be there, many-to-one functions will be there, constant functions will be there, into functions will be there, onto functions will be there. All functions together gives you the total number of functions. But for one function, it is NPR, please. NPR. Just I'm revising. Obviously, many-to-one function means two elements will have the same image. Just say this. x1, x2 has y as image. x3, x4 has y as image. Such functions are said to be many-to-one functions. All non-one functions are many-to-one functions. Anyone in the class, do you tell me the formula to find out many-to-one functions?
All functions minus 1-to-1 function.
Very good, Vida. Very good. That is Dhananjay. Rest of the people are sleeping. Where?
Yes, sir.
Jahan, Parsh, Sakshi,
Yes, sir.
n power r minus npr, beta. Total functions minus 1 function gives you the many to one functions. Okay. In fact, the instructions in teaching advance is not to revise all these concepts, straight away jumping to the problems, but which I cannot do that. I cannot do that. That's the reason why I'm taking some of my time to revise the things. And onto function, you have the separate formula. Generally, the proof is beyond the syllabus. Proof is beyond the syllabus, and hence this onto function, I can say confirmedly that the questions were given almost in every examination, not only in functions, but it is linked up with the permutations, combinations, even probability also. This onto function, number of onto functions case is given. So it is like this: sigma minus 1 whole power n minus r into NCR into r power n. If you write r is equal to what? It is minus 1 whole power n minus 1 into NCR into r power m. Just remember like this, please. Remember like this what I'm saying. N power r, total functions, no? Minus NC1 into n minus 1 whole power r plus NC2. I gave you this already. Just verify. You have to revise it, please. Whole power r minus NC3 into n minus 3 whole power r plus and so on. You may be surprised, sir, how many terms are to be written like this. Generally, it is limited only to maximum of 3 only he goes. Maximum of 3 only he goes. So up to this only you have to remember. So if it is n is 2, no, it ends up here. N is 2, it will be 2 power r minus 2. That's it. What is this 2 power r minus 2? You have to understand like this. If there are two elements here, for example, x1, x2, and if this there are something like x1, x2, x3, x4, let me say. I'm showing this, just a moment. Just a moment, I'm revising it. Follow this carefully. Number of onto functions I'm discussing about. So, what happens? Why that minus and plus alternative comes, why that plus and minus comes alternatively. For example, I have taken some x1, x2, x3, x4 here, and y1, y2 here, for example. Then I will write total number of functions as 2 power 4, there's no doubt in it, which consists of all 1, 1, on 2, many 1, and all constant functions, everything is contained. But I'll have such cases where it is not onto function. Onto function definition, according to onto function definition, everyone knows no element of the codomain or range should be left without pre-image. This is not onto function. So subtract it. This is one case. This is one case. Similarly, for y2 also one more case will be there. So this is the formula. 2 power n minus 2 if you have only two elements here. So that's what the formula is. Just now I wrote that. I might have given a test n power m in your notebook if you verify. It is n power r minus nc1 into whatever it is, you must be in a position to understand. N minus 1 whole power r plus nc2 into n minus 2 whole power r minus and so on. Like this it goes. This is number of onto functions is very, very important what I'm saying. So number of onto functions, number of into functions. What are the number of into functions? Into functions means exactly opposite to onto functions. Whatever the formula is there for into onto functions, and you have to subtract the total formula from n power r minus onto, gives you into. The definition is also exactly opposite to onto functions. Exactly opposite to onto functions. That means at least one of the elements in the codomain must be remained without pre-image. At least one of the elements in the codomain must be remained without pre-image. Then it is said to be into function. So method to find out onto and into functions, just you revise them, please. You revise them, and it is no element of the codomain should be left without pre-image. No element of the codomain should be left without pre-image. Then it is said to be onto function. So if any such element is remaining, then we say that it is not onto function. Just for the revision's sake, I'm taking an example like this. F is mapping from n to n such that f of x is equal to x plus 1. Anyone, do you tell me whether it is onto function or not? Anyone, please? Anyone in the class?
Onto.
Is it onto?
Yes.
You said
Yes.
yes, but it is wrong. If you take the domain elements as 1, 2, 3, 4, and the range elements are also 1, 2, 3, 4, 5, and so on, and if you map this, what happens? If you map this, what happens? 1 maps to 2, and 2 maps to 3, 3 maps to 4, or 4 maps to 5. What about this? No pre-image, and hence it is not a onto function. So not an onto function, please. Okay. So that's about onto function. And next is polynomial, integral function, and different types of functions are given. These are all known to you, trigonometry functions and different trigonometry functions. Just now Dhananjay is saying they are not included in the syllabus of 12th class, he's saying, but it is not like that. Different mathematical relations, what all are defined as functions, will be there included. So there are not restrictions, no restrictions for functions. Similarly, the domains and ranges of different inverse trigonometry functions. I think you did not finish this, no? Respond, please respond. I'm revising
No,
the
sir.
things, and I would like to know whether you know this or not. Inverse trigonometry functions, domains, and ranges. Every one of you respond. Should I stop teaching?
We know this much.
I want to understand whether this is known to you or not, whether it is finished in your main level or not. I want to know that.
No, sir.
Yes.
If it is not
No,
there, then
why?
I have to discuss at length. You're not understanding my pain here.
But you have taught us.
You're all just sleeping. You're not answering my questions there. What I'd like to ask you here, whether you know this domain and range or not. Yes. I have not received the reply.
Yes, sir.
Yes,
You know this?
Yes, sir. Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. In the previous classes, you said that you don't know about this. Inverse trigonometry functions not yet finished.
The chapter is not yet started, but you taught functions में सिखाया था.
आपने सिखाया था ये सर.
अच्छा, चैप्टर नहीं हुआ.
नहीं सर.
ठीक है, वो हो जाएगा. So this is also an important. This is, you understand the importance of this because it is given as a separate chapter, inverse trigonometry functions. Why the restriction like this instead of sin x? In fact, what should happen? I'm just revising that also. Just a moment. If you take sin x, sin maps from set of real numbers to -1, comma, +1. Then sin inverse must map from -1 to 1 to R, which is wrong. It is inverse. Why is it wrong? The definition of inverse in the functions f maps A to B implies f inverse maps B to A is possible if F is a bijection. Again, I'm asking you, what is a bijection, please?
Each and every element.
One and one under.
Onto.
By stands for 2. So it is both 1 and onto, please. It is both 1 and onto. Then only it becomes a bijection. But sine function taken as this is not 1 function, because sine 30 degrees 1 by 2, sine 150 degrees 1 by 2. Similarly, sine 390 degrees 1 by 2, like that. Many elements will have the same image, and hence it is not a 1 function. No trigonometric function taken as it is a 1 function. That is the reason why what the mathematician did. He restricted the domain. He restricted the domain between minus pi by 2 plus pi by 2, then inverse is defined. This is a very, very basic point you must know. You must understand. That is the reason why it has become a big chapter. Big chapter because of these restrictions. This is inverse. But this is not carried directly. Just observe it. This is not carried directly, but it is carried with restrictions. The reason is the definition. It should be a bijection. This is what I'd like to tell you this. That means whenever you write the value of sine inverse x, it should never be less than minus pi by 2 and it should never be greater than pi by 2. Very, very important point, please, with regards to the inverse of trigonometric functions. Okay. Now, this is exponential function. The graphs, just remember the graphs of it. This is y is equal to a power x. A is greater than 1. Y is equal to a power x. A lies between 0 and 1. That means less than 1. Less than 1. Then graph is decreasing here. Here the graph is increasing. And logarithmic function is just a reciprocal. I must say that logarithmic function is inverse of a power x. Just remember that. Inverse of a power x. How do we see this? Just see. Inverse of any function, very, very important point for advanced here. For advanced concepts, it is very, very important. If you take a line, I'll change the color, just a moment. If you take any function, and if you want its inverse, inverse and the function, inverse and the functions will be mirror image in the line y is equal to x. Just observe the below graph. Observe the below graph, please. It will be just a mirror image. It goes like this. So a power x inverse is log x, please. Similarly, just observe this also. Here also, it takes a mirror image. Mirror image. In the line y is equal to x. So whenever a function is there, if you want to draw the graphs of the function and its inverse, graphs of the function and its inverse, there will be mirror images in the line y is equal to x. There are mirror images in the line y is equal to x, please. Okay. That's what it is. Now, these are different types of functions. Identity function is nothing but y is equal to x. Whatever the value you give, you'll get the same function. Okay. We'll be revising more whenever we get the problems related to it. Just now I have shown you greatest integer function and modulus functions. Just revise those graphs. Graphs are important there. Graphs are important because by knowing the graph of any function, you can have the entire structure of the function, the entire history of the function. You can understand. So, knowing the graphs of different mathematical functions is very much essential for the advanced level examinations. This is y is equal to mod x here. This is y is equal to step x here. Greatest integer function. And anyone, do you tell me whether y is equal to mod x is 1 function or not?
No, sir.
No.
Why?
Sir, it is because we have x में 2 not y में. It's a 1 function.
If you draw a line parallel to x-axis, it is intersecting in 2 points. Just check it out. And hence it is
So,
not a
but
1 function.
we draw parallel to y-axis, right?
No, parallel to y-axis for the function.
Again, it is a function or not.
To check the function, we draw parallel to y-axis. To check 1 function, we draw parallel to x-axis. Okay, now, similarly, greatest integer function. Now, let us see the Signum function. Signum function, mod x by x not equal to 0 is equal to 0 if x is equal to 0. Very important, please. Very important one, Signum function. Just remember this. The range of the Signum function is only 3 elements, -1, 0, 1. This is -1, this is 0, this is 1. This becomes 0. It is defined to be 0 when x is equal to 0. You may be getting down mod x by x, how it becomes 0. But it is mod x by x means it should be a constant and it is defined to be 0 at x equal to 0 and hence it takes this point. It takes this point. For all the positive values of x, it takes 1. For all the negative values of x, it takes -1. This is -1. Like this it is. Signum function. Next, reciprocal function. Y is equal to 1 by x. Y is equal to 1 by x. It extends from 0 to infinity like this, and it extends from -infinity to 0 like this. This is, do you recognize this shape in the geometry?
Rectangular hyperbola.
Rectangular hyperbola. It is a rectangular hyperbola. Xy is equal to c square. Okay. Domain and range of some standard functions. This is the table to be, I have forgotten to ask you to take the screenshot of it. Just take the screenshot of this. Every one of you, please take the screenshot of this. This is inverse trigonometric functions separately. Is it done?
Yes, sir.
Are you awake? Everyone is होश में है ना सब लोग?
Yes.
जहान का तो उठ के करना पड़ेगा.
Yes.
Yes, sir.
प्रथमेश का नहीं हो पाएगा ना ये. प्रथमेश का स्क्रीनशॉट नहीं हो पाएगा.
Sir, I took the screenshot.
Yeah, Prathamesh is talking. Wow. You're on now, Prathamesh?
Yes, sir.
Good. अभी साफ हो सीधा हो गया क्या आपका ये माइक?
No, sir, I logged in using a phone.
You're using the phone now?
Yes, sir.
But don't do that. Use the bigger screen now. If you use phone now, then your eyes strain will be very high. So at least you all use minimum a tab. Minimum tab must be used. Occasionally, if it is any problem is there, then you make use of the mobile. Okay, so that is the domain and ranges of standard functions. Take the screenshot of this also, please. Still more are there. I'll be moving it. If you say okay, I'll be moving.
Okay, sir. Yes, sir.
Yeah, I'll reduce the size of it. Just a moment. Yeah. Just a moment. Yeah. It can be now. One moment. Yeah, take it, please. Take it now. Okay, these are the things to be revised. Very important, please. Very important. the domains and ranges of different functions. And next part of it is odd function, even function. It should be, I think, odd function. Everyone knows f of minus x is equal to minus f of x. Even function is nothing but f of x is equal to f of minus x is equal to plus f of x. And graphically, for the purpose of advanced, you must understand the even function and odd function. Even function and odd function like this. If you take a function which is even, let me say, f of x is equal to x squared. Do you accept this is an even function or not?
Yes, sir.
Yes.
So even function always lies in the adjacent quadrants, symmetric in the adjacent quadrants. Like this, it will be. So whatever the shape is there in the first quadrant, the same shape will be there in the adjacent quadrant. This is the nature of even function, whatever. Similarly, fx equal to x cube is there. Do you tell me whether fx is equal to x cube is even or odd?
Odd.
Odd.
Symmetric
Odd
about
function.
origin.
So odd function is symmetric in the opposite quadrants. Just say this. Like this it goes. This is what you have to understand, please. Always odd function is symmetric in the opposite quadrants, and even function is symmetric in the adjacent quadrants. You have to understand this for the advanced level questions particularly. Okay, so coming to this one is done. Even function or odd function is done. Oh, that's what he has given here. This point is also given. The graph of Dhananjay, पढ़ो बेटा एक बार ये.
The graph of even function is always symmetric with respect to y-axis.
Yes. अरे साक्षी,
सर
लेट आई थी आज ना?
नेट इश्यू था, पहले मोबाइल से कनेक्ट किया था, अब लैपटॉप से.
ठीक है, ये पॉइंट पढ़ो बेटा जो मैं दिखा रहा हूँ इधर.
The graph of odd function is always symmetric with respect to origin.
Origin. मैं तो opposite quadrants बताया, उन्होंने with respect to origin बताया. The product of two even functions is an even function. The sum and difference of two even functions is an even function. The sum and difference of two odd functions is an odd function. The product of two odd functions is an even function. The product of two odd functions is an even function. The product of an even and odd function is again an odd function, like plus into minus. Plus into minus, a minus into minus, like that. Okay. The sum of even and odd function is neither even nor odd. Zero function is only function which is even and both odd. Even and odd both. It's a zero function. Okay. These are all main level questions. If you revise your book, that is, if you take out your notebook, you will find all these questions there. And periodic function, very, very importantly, periodic function. I have already explained you in the previous classes, somewhere in the matrices also. This is f of t plus x is equal to fx, and the least positivity is called the fundamental period of the function. Fundamental period of the function. So different trigonometric functions, periods are given here, and period means very simple. I explained you in a simple way. Period, fundamental period, or periodicity means which repeats in a particular interval. The repetition takes place. Whatever the graphical shape is there in a particular interval on the positive side of x-axis, it repeats. That minimum value is said to be the period. That's it. Sin x repeats between 0 and 2 pi. That is why period of sin x is 2 pi. And period of cos x is also 2 pi. Period of tan x cot x is pi only. Similarly, reciprocal secant x cosecant x will have the periods 2 pi only. Okay. Similarly, modulus is there. Then what happens to the graph? I need not have to explain you. Everyone knows whenever mod sin x is there, the graph will be turned. The graph will be turned as hills like this. The below part comes above x-axis. The below part of x-axis comes above x-axis. So it repeats between 0 and pi, mod sin x. But mod sin x plus mod cos x again differs. What I mean to say by mod sin x plus mod cos x, no, it repeats in pi by 2 interval only. You can verify this, of course. If the answer is straight away given, if the answer is straight away given, then you can verify the options like this. If you want to confirm whether pi by 2 is the fundamental period or not, replace x with pi by 2 plus x. Replace x with pi by 2 plus x. Then it will become mod cos x. And it will become modulus of minus sin x. Even then it becomes plus because modulus is there. Function repeated. Just check it out. So the period of mod sin x plus cos x is pi by 2 but not pi. But not pi. It differs, please. It differs. So you must be aware of the definition. And one more very, very important thing is that the algebraic x minus step x, just now I explained you. Its period is 1. Its period is 1. I have shown you that. Now, algebraic x functions like root x, x square, x cube plus 5, etc. The period does not exist. So, very important point to remember is that every mathematical function need not be periodic. Like in the nature, I have taken the example in the nature also. In the nature, some functions are periodic, some are not. So like this. If you take the coronavirus, it is not periodic. If it is periodic, it will be difficult for the humans to live on this globe. And even if it is periodic, humans will have more and more resistance to face it also. Either of the things happen. Though it is not periodic. Like that in the nature also. Some are periodic, some are not. And if you want to find out the period of different functions that are in addition or subtraction or multiplication or division, then you have to take the LCM of individual functions. LCM of individual function. If it is an even function, what he is saying, half of the LCM. Why? Just now I said it goes like hills, mod sin x. But what is sin x? Period 2 pi. And mod sin x is an even function, and hence it is 2 pi by 2. That's what he means to say here. 2 pi by 2. Okay. Because it is to be randomly revised, I have taken up all the concepts. So everything is covered. And finally, this is composite function. Composite function. Composition. This I have taken an example and explained you previously. If there are 3 functions like this, f, g, h. F maps A to B, G maps B to C, then G circle F maps from A to C. Important, please. G circle F maps from A to C. So this is A, this is B, this is C, and I took the example of car at that time, if you remember. A car is to be manufactured. Then this is the raw materials. And this is the parts of the car. Then to make the car, you must have the parts made from the raw materials. The parts must be made from the raw materials, and these parts assembled to make the car. These parts are assembled to make the car. So, if this is a function from A to B, and if this is the function from B to C, then finally we can say this is A to C. This is what the composition is. Therefore, we finally say that G circle F maps from A to C. G circle F maps from A to C. That's what it is. So here you can see how to write the composition. The codomain of the first function must be equal to the domain of the second function. Then it will be removed. It will be removed, and you have to talk it from the right hand side. G circle F. G circle F maps from A to C. A to C. That's what. Car is made from the raw materials. This is what you have to understand, please, with regards to the composition of functions. Little tricky, the problems will be, I should not say difficult. I should not say difficult. Nothing I'll say difficult. So this is to be understood. That is why I have taken an example. I have taken an example like this. F maps A to B, G maps B to C, and B is common. It is a codomain of F, and it is a domain of G. This should be common. Then only composition is possible. And the composition goes like this. G circle F maps from A to C. G circle F, right side to left you have to go. G circle F maps from A to C. Like that it is. Okay. That's about the composition of two functions. You have to revise all these things. Okay. Now, G circle F whole inverse. Generally, you might have seen even in matrices also, you might have seen this. It always splits from right side. It always splits from right side. Just see this. G circle F whole inverse is nothing but F inverse circle G inverse. F circle G of X is equal to G circle F of X. It need not always be equal. But if it is mentioned something like that, this is a theorem in fact. Check it out whether this theorem is there in your 12th exams or not. If it is there, no, generally you will be given theorem in functions for long answer. For long answer questions, it will be given. You have to learn that. Okay. Inverse function, I already discussed. F maps A to B can be written as F maps A to B can be written as F inverse maps B to A. When can we write this? Anyone in the class, please?
Bijection.
If it is a bijection. What is a bijection again? It should be both.
1 plus on 2.
It should be 1 or not. If it is not, you cannot write that. That's the reason why this is very, very important. And there is a complete chapter formed on this, on the definition of this basis only, which is inverse trigonometric functions. Because no trigonometric function taken as it is a bijection. No trigonometric function taken as it is a bijection. But the mathematician restricted its domain and defined the inverses of trigonometric functions. Okay. That's all, please. That's all the theory part of it. And anything left over, I think almost everything is covered. Anything is needed in between, we will be discussing. Okay. Now let us check it out. Come and start doing the problems, please. Every one of you, it is multiple correct answer type. And what I appeal you, just revise all the concepts on your own. Refer back to the notes given in the main level. Come and do that, please. Yeah, now it is. Fx be a non-constant polynomial satisfying the relation. This is called functional equations. Functional equations. the function is indirectly given in the form of equations like this. So f of x into f of y is equal to f of x plus f of y plus f of xy. Think of the devil. Think of the devil is Priyanshu. Just now she entered the class. So f of x into f of y is equal to fx plus f of y plus f of xy minus 2. And I think some printing error is there. And f of 0, I think, is not equal to 1 or is equal to 1. Let us check it out. No problem. Suppose f of 4 is equal to 65. Then f dash x is a polynomial of degree 2. Roots of f dash x is equal to 2x plus 1 are real. X into f dash x is equal to 3 into f of x minus 1. F dash of minus 1 is 3. F dash of minus 1 is 3. Okay. Now, how to solve this type of problem? Generally, by giving random values to x and y, you have to solve them. So, put x is equal to y is equal to 1. Come on, tell me then. What will it be then? This is f of 1 square. Are you there, everyone?
Yes, sir.
Yes.
Minus 2f of 1 plus f of 1, that is, it is minus 3f of 1 plus 2 equal to 0. Then you can have factors f of 1 minus 1 into f of 1 minus 2 equal to 0. So f of 1 is equal to 1, or f of 2, f of 1 is equal to 2. Because it is given to be a constant polynomial, f of 1, just check it out, f of 1 is equal to 1 will not be satisfying that, and hence you have to take f of 1 is equal to 2. F of 1 is equal to 2. Then, if you write, you have to derive the function finally. You have to derive the function finally. Then, if you write f of 1, 2, then what will it be? I repeat what I'm saying. I repeat what I'm saying. F of 1 will not be 1, because if you write that, in the question it is given that it is a non-constant polynomial, it will not become a non-constant polynomial. That's the reason why it is not equal to 1. Now, if you substitute f of 1, 2 here, are you there, everyone?
Yes.
Are you there? F of 1, 2 here. X equal to y, let me write. Then what is that you get? Or replace what I'm saying. Replace. Just a moment. Replace y with 1 by x, please. Come on, tell me. What will it be then? Replace y with 1 by x. F of x into f of 1 by x is equal to f of x plus f of 1 by x
Plus f of 1.
plus f of 1, 2 minus 2. Getting cancelled. Then you must ask me, sir, how do we get these ideas, sir? You have to get. There's no other go for this. After practicing more and more problems only, you will be able to get these ideas. We don't have any alternative for this except working out on your own. Now, this is a standard function. I gave you special functions. I gave you special functions. Special functions means whenever functional equations are given, you cannot derive all of them. This is a special function given. Like that, I have given you some 5 special functions. Just revise them. Revise them. Then whenever this comes, you have to take fx as 1 plus or minus x power n. Whether plus is to be taken, minus is to be taken, according to the given value, you have to decide. What is the given value here? F of 4 is equal to 65. So f of 4 is equal to 65. You tell me, please. You tell me f of 4 is equal to 65. Write it here, please. Implies f of 4 is equal to 1 plus 4 power n. I'm taking plus first. But what is f of 4 given? 65 is equal to what? 1 plus 4 power n. Then n is equal to 4 power n is equal to 64. 64 is 4 cube, n is equal to 3. Therefore, your fx finally derived. What is your fx now? 1 plus x cube is your fx. 1 plus x cube is your fx, please. That's what it is. Now check it out. F dash x is a... Alright, you have to answer now, please. Everything I did, you have to tell me the options which are right there. Don't see the answer given in the bottom. Even if you see also, you don't take it into account, because for the reference purpose, whenever we are solving the problem, sometimes we may go wrong. Sometimes we may go wrong. That's the reason why I'm taking the key there, key.
So A is
A is
correct.
correct because f dash x becomes 3x square. Second one,
B is also correct.
why b is
3x.
correct?
So क्योंकि ये 3x square is equal to f dash x आ गया, और अगर हम लोग 1 substitute कर दे
3x square minus 2x minus 1 equal to 0, you will get roots for this, real roots for this. B square minus 4ac is greater than 0. So A correct, B correct. X into f dash x.
C or D भी correct
Huh?
है.
C or D be correct. Yes.
Yes.
C or D be correct.
What is f dash of minus 1, please? 3x square minus f dash.
3x square. 3x cube.
3x square, no? 3x square.
No sir. 3x cube. This.
You're
Sorry.
talking about C, na?
So
Okay, okay. MJS, MHWS.
So आपको x equal to y equal to 1 लेके क्या मिला?
क्या बेटा x equal to?
जो y equal to 1 लेके जो किया, तो उसका क्या यूज है अपने को?
ये f(1) is equal to 2 आया ना बेटा?
So but
अगर वो
ये
नहीं आया तो कैंसिल नहीं हो पाएगा इधर.
समझा.
Sir, can we find out the function by this way? We'll first partially differentiate with respect to x, then with y, and then we'll compare.
So I never tried that part. You try it. I don't know exactly whether it happens or not. I have to check it out. Okay, this is the method to solve this problem, and all ABCD are correct there. Let's go to the next one, please.
सर
बोलो बेटा.
मैं पहले से ही थी क्लास में.
बीच में बाहर
अभी
गई.
नहीं. सर
बीच में नेटवर्क प्रॉब्लम हो गया क्या?
हाँ, मैं इधर आ रहा था. Zoom is not responding, तो मैं फोन से ज्वाइन कर रही थी.
ठीक है तो वही है रे. तेरे बारे में सोच रहा था, तू आ गया अंदर, इसलिए बोल रहा हूँ. ठीक है. F maps R to minus 1 to infinity and f of x equal to ln of step of mod sine to x plus mod cos to x. Step of greatest integer of mod sine to x plus mod cos to x, where this is greatest integer function. where this is greatest integer function, then R minus intersection range of f is null set. Fx is periodic but fundamental period is not defined. Fx is invertible in 0 comma pi by 4. Fx is into function. Now, the important thing to be remembered here, what is the range of, because he's talking about range here. Now, if I take mod sine 2x plus mod cos 2x, mod sine 2x lies between 0 and 1, mod cos 2x lies between 0 and 1, and step of it, anyone please respond. Mod sine 2x plus mod cos 2x, we are talking about how its value will be. That is, I mean to say, what is its range?
For range, so max, so we can use that formula.
Huh. It is lying between 0 and 1. It is also lying between 0 and 1. You can make use of that formula. What Dhananjay is talking is this one: a cos theta plus b sin theta plus c belongs to c minus root a square plus b square comma c plus root a square plus b square. This is what, you're talking about this only, Dhananjay?
Yes, sir. So 2 root 2 are there. Maximum value.
So it lies between 0 and root 2.
Yes. So, but it cannot be 0.
Yeah, it cannot be 0. That means it is less than, if you write the same formula here, it is root 2. So it should be less than or equal to root 2. Okay. So when you substitute that here, log of root 2,
greater than 0.
it is always greater than 0. It is always greater than 0. Okay. So you can say that will never become negative. Range is always positive. And hence, the first option is correct because it is a null set. Fx is periodic, but fundamental period is not defined.
हाँ तो वो भी true है.
Because
we don't know the minimum value.
Because whenever it is a logarithmic function, obviously it won't be periodic. But because inside you have mod sine 2x plus mod cos 2x is there, it becomes periodic if without logarithm. It becomes periodic without logarithm. But fundamental period cannot be defined. What is the meaning of fundamental period, first of all? For example, if you take fx equal to sin x, what is f of 2 pi plus x, please? Sin x only. What is f of 4 pi plus x? Sin x only. What is f of 6 pi plus x? Sin x only. So this is called fundamental period. The rest all periods only. 4 pi is a period, 6 pi is a period, but fundamental period is 2 pi. Like that, for this one, you can say what he means to say. What he means to say, mod sine 2x plus mod cos 2x is periodic, but because logarithm is there, you cannot say it's fundamental period. So that's what is also correct according to me. Now fx is invertible in 0 comma pi by 4. First of all, inverse definition, please. Definition of inverse. It should be 1, 1 and on to. It should be 1, 1 and on to. I am just revising the method what we follow to find out the inverse, which is very important even for your board exam also. Let us write this. Let y is equal to f inverse of x. Implies x is equal to f of y. X is equal to f of y.
We can directly substitute 0.
In this one, you meant to say?
Yes, we'll get log of 1, which is not.
Log 1 is 0, no?
Yes, sir.
If you substitute pi by 4, then also you'll get log 1. 0. Yeah. You are getting not invertible. Not invertible.
It's not invertible.
You understand what Dhananjay is saying? Just see that. If you put x is equal to 0, comma, pi by 2, what is that you are getting? F of 0 is log 1, 0. And f of pi by 2 also 2 into pi by 2, no? Cos pi, 1. That is also 0. That means two
Yes,
elements
sir.
has the same image. Pi by 4, please. Pi by 4. Two elements have the same image. And hence it is
T is
not
also correct.
what? It is not what?
1, 2.
Invertible.
Not 1, 1. And hence it is not invertible. Not 1, 1. Because some
D is
elements
also
will be
true.
left over in the codomain, it is into function. Exactly, into function is exactly opposite to onto function. It is proved that it is not 1, 1. And even it is not onto also because you have in the, just to see in the codomain, please, in the codomain, are you there everyone? What is the codomain of the function here? -1 to infinity. Many elements will be left over without pre-image. Many elements will be left over without pre-image. So fx is into function. And fx is not invertible. Fx is periodic, but not fundamental period is not defined. And range is always positive.
Sir, hello, sir. Sir, please can you explain the second option again?
Yeah, because mod sine 2x plus mod cos 2x individually, if you take without logarithm, see, I'll tell you with an example like this. If you take a function fx equal to x, for example, then if you draw the graph of it, this is nothing but fx equal to x, y is equal to x. Okay, just a moment. Just a moment. I'll give some value here. F of x equal to some k, let us take. Then how the graph of f of x equal to k will be? It is just like this, parallel to x-axis. Do you accept that it is periodic or not?
Yes, sir.
It is periodic. It is periodic, but fundamental period not defined in this case. Fundamental period not defined in this case. So such thing happens for log of this one. I'll show you the graph of it in the next session. I'll draw the graph and I'll show you the graph of it in the next session. Okay? That's all for the day. We'll be continuing in the next session. Yes, please.
So, sir, you solely just judged the graph of it. And on the basis of it, you said that f of x is periodic, but fundamental period is not defined.
Yes, yes.
Yes, sir. Thank you.
We'll continue this in the next session.
Thank you, sir.
I have taken all these one or more correct questions. We'll be discussing this in the next session.
Thank you, sir.